Hi, this is Jacob Nash with JNGL. This is the Unit 5 review that I made, and sorry that it's not like in a presentation. It's in a PDF so that I can write on it, that's why. So let's see. Alright, so the first thing we talked about in this unit was translations. It is a rigid motion. Remember, a rigid motion is, will it be congruent after you have done the thing that you're trying to do, the transformation. And yes, you're just moving it in this case. And this picture right here shows you what it's like. You can move it. That's all it is. People will call it, a slide, And these triangles don't look the same, but too bad. Let's pretend like they are. Function notation. Okay, well, there's different notations that you'll have to know. And function notation is when you have the letter T for transformation, and then you have what you're changing it by, and the what do you call those? The things that are by the period and comma. But yeah. Coordinate notation is X, Y, arrow, and X and Y is the change, and then X plus N. So X, or actually, sorry, that's not correct. X and Y will be your point, and then N this time will be what you're changing it by. Vector notation is just the function notation without the T. That's all it is. So here's an example. Let's say, you have a point 5, 1. Make it go up, 2, and then right 3. All right. Well, first of all, we need to pick a notation. I'll do each one. So if it's to change, we know that this is the Y, so it would be right here, and this is the X. So 3, 2. That's what's being changed. It's going right 2 and up 3, and those are both positive movements. And then for this one, it would be 5, 1. X for the X and Y, and then it's going to be 5 plus, well, it says plus or minus, but this case it's going to be plus 3, comma 1 plus 2. And then vector notation is just going to be 3, 2. So you have to know these names and how they are, so be careful with that. This is the easiest one to calculate from, so we can see 5 plus 3 is 8, and then and 1 plus 2 is 3. So if we did that translation, that's the new point that we'd get, 8, 3. All right, now reflections. Reflections, this is also a rigid motion. It stays the same, it just is in a different way. So notation, we have the uppercase R. Remember, it has to be uppercase because lowercase is rotation. And then A is what axis you're reflecting it on. It could be X plus 1 axis. In that case, there's no rule, but these are the rules that there are. And if you reflect something over the X-axis, the Y goes negative. If you reflect something over the Y-axis, the X goes negative. Oh, wait a second. Something's not right. Yeah, I don't know why it says Y negative X. That's not true. It is, let me cross that out, is negative X, Y. Don't know why that happened. Sorry, that's wrong. It's negative X, Y. And if you reflect it over the Y equals X, which means that it starts at the origin and then it goes positive 1, 1 slope. And then Y equals negative X is just the one that goes down like that. And so let's say you need to reflect the point 4, negative 1 over the let's say X-axis. So the Y goes negative. If it's already negative, then it becomes positive. So that's what it would be. It would be 4, 1. if you need to reflect that over the y equals negative x, let's just say, they switch places, so it would be negative 1, 4, but then they both turn negative. So we have this, but the next step is to change their signs. This goes to 1, this goes to negative 4. So if we're reflecting it over the y equals negative x, then do that. And it might make more sense if you did the work on the graph, but I just don't have one here. All right, then we talked about rotations, and I should change my marker color because it will not show up on red. It's also rigid motion. You're just turning a different way. And you always should assume that you're rotating counterclockwise. So think, what way does the clock go? All right, the hand goes this way. Counter means not, so it's not going that way. It's going this way. So it's not that. You usually do that. If it says that you're going clockwise, then do that. The notation is just R, that's lowercase, N. N is going to be the number by which you rotate it. So it's usually going to be 90, 180, or 270. At least that's all I had to know. Point is what point are you doing it by. So X, Y, or just P. I'm just going to put P. I always forget the Control Z does not work on this. I usually try to do that if I'm trying to delete something I did. All right, rules. If you're rotating something 90 degrees, then the Y goes negative, and they switch places. If you're rotating something 180 degrees, nothing switches, but they both go negative. And 270 degrees, then they switch places and the X goes negative. So let's say, rotate the point. You usually have to do figures, but we're just doing points in this example. Rotate the point 270 degrees, okay? So if you forget these rules, you can always just go on the graph, and I can't explain that right now because we don't have one, but if you want to see how to do that, go to the video, Unit 5, Lesson 3. So 270, they switch places, okay? And then the X goes negative, so the X is that. So if you rotate 270 degrees, that's what it's like. All right, dilations. This is not a rigid motion because dilations is when something gets bigger or smaller. Think about when your eye gets dilated. Hopefully that doesn't happen to you, but sometimes that happens if you have an eye issue. That's not the case for me. But notation is D, uppercase D for dilation, and then scale factor, SF. And really, you could use any letter for this. This is at least just how I knew it. Scale factor is how much you'll do it by, so it might be 3 or something. Enlargement is when something gets bigger. I mean, you see the word large in it. And reduction, well, something's reduced, like, oh, my dad's fees got reduced. Yay. Or something like that, yeah. Okay. To find a dilated point, so it's like dilate this point by this scale factor. Well, you have to multiply it by the scale factor. If you're trying to find the scale factor, it doesn't. Never mind. It does say. It says right here. Do image divided by pre-image of the points. You can use either the X or the Y, and I'll show you an example. So, okay, let's say we have the point 1, negative 5. 1, negative 5. Multiply or dilate that by the scale factor of, let's see, by 3/2, or it might even say 1.5. But in my opinion, it's easier to do it when there's fractions. Hopefully you'll have a calculator, but if you don't, it might be easier to do fractions because you can do that. But we just go point by point. And anyways, I'm just going to use my calculator to make things quicker. Let me try to pull this up here. Okay, 1 times 1.5. Well, that's just 1.5. I don't know why that didn't come to me first. So 1.5 would be the first thing, and then the next point would be, okay, so negative 5 times 1.5. That is negative 7.5. Or you could do fractions if you wanted to. Okay. Anyways, that's what you do. But if you're trying to find the scale factor, let's say, you went from 4, now you're at 2. And let's say this is the image, this is the pre-image. So image over pre-image, 2 over 4 reduces to 1 over 2. So there's a scale factor of 1/2. Okay. And Symmetry, Symmetry was the video that I did where it was like not a screen recorded thing. And but line symmetry is if you're folding something in half on a line of symmetry, which is that dotted line, and if it has line symmetry, then it's able to do that, at least in one way. Point symmetry is if something can be turned upside down. It's the same thing. This N, if you turn an N upside down, that's uppercase, it's still the N. And this might look slightly different just because of the font, but rotational symmetry is can something be rotated by a certain degree to still be the same figure? And this is an example, this 7-pointed star, and how you find what degree each thing is by, like from here to here, from here to here. Well, you take 360, because that's a full turn, and you divide it by how many sides there are, that's 7, and then that comes out to be about 51.4. So if you turn this figure by 51.4 degrees, then you should get the same figure. And remember, if something has point symmetry, then it has rotational symmetry. Why? Well, if you turn it in upside down, that's 180 degrees. And yes, that's less than a full turn, so that is a thing. Thanks for watching. So what's next? You can email me if you have questions at jacobnash747@gmail.com. Well, except the fact that I might not answer if it's like a few years later. Sorry, that's probably like the least reliable one, but you could watch other videos, you could always do that. Or you could watch other channels, because maybe I don't explain enough. I mean, I'm not a professional, obviously. And then ask your teacher, unless star. That's just something you can fill in if you really don't like your teacher. And then, yeah, I mean, like, your teacher should be good, but I know that there's some that are not good, because I had a teacher that would not help before, but my geometry teacher did help, at least. I mean, obviously, that's how I know all this anyways. And then good luck. If you're having a test, good luck. Or, and here's the other thing. I happen to know that after I took my Unit 5 test, I did have a midterm, so I will try to make a midterm review thing. Alright, so you can look for that if that's what you're looking for. Alright, thank you for watching.